Good morning, everyone. Morning, Julia. Morning, Danielle. Morning, Anthony. Morning, Cheryl. Okay, so yesterday I had done section 2.3, introduced you to all of these formulas, all of these area formulas. So we actually did one of each of these, the shapes that you're seeing now, with me demonstrating how to use the formula for each one. I'm sure a lot of you have seen those figures before. You might have been a little rustier on your volume, so I demonstrated one of each of these also. Those problems I had pulled from some additional worksheets that I included because there weren't enough, in my opinion, in the lessons note packet. There was only 2, so I did those worksheets that included one of each of these, and then I did the 2 that were in the lessons note packet as well, because I wanted you to take a look at what it means to give an exact answer as well as an approximate answer. So I was practicing on that with you, which is why I did 2 extra problems, even though I had already done the circle in the worksheet and I had already done the sphere, because I just wanted you to get used to giving an exact answer where you leave pi in, and then giving an approximate answer that goes with it, where you just put in your calculator 16 times pi. You touch the pi symbol if they don't make any mention of using 3.14. If they say use 3.14 for pi, then you press in 16 times 3.14 instead of touching the pi symbol. So, either way, they can answer, they can ask the question. Likewise, I did the same thing for circumference. The whole section was about the fact, how do you guide yourself by way of a formula? You write it down first, and then you plug the numbers into the formula that come from the picture. So that's what all 18 examples were about. I think there were approximately that many by the time everything was said and done. It took me the whole period to give you one of each of those. So as I've been saying all along, just some ideas, just some comments and suggestions for those that are not doing well on the end of class activities. It is possible that you're just not taking notes and examples, because really that end of class activity comes right from the notes. I just picked some problems just to make sure that you can do it on your own and not just watch me, and I changed the numbers. So if you have that sitting in front of you, and that becomes a lot more important in chapter 2, because chapter 1, you didn't really, I don't know how many examples you really needed except for the Venn diagrams and the degree type problems. I mean, there's certain things that, yeah, it's really helpful to look at an example or a picture. That becomes much more important in chapter 2 because of the variety of things that you are doing, and they're on a higher level, a higher cognitive level than Chapter 1. Chapter 1 was just some really introductory type stuff. And then, as you can probably sense, this is a little bit harder because there's formulas for everything. So you do have an example, and you can be looking at all the examples that I gave you, and you will see some of those on the end of class activity. Today we're going to concentrate on how to convert from one unit to another. We're going to be working in the English system, where we use inches, feet, miles, things like that when we're measuring length. When we're measuring liquid or volume, we talk about gallons and pints and cups. But we're also going to be looking at the metric system, where when you're doing volume, you talk about liters and milliliters, things like that when you're doing volume. And when you measure length, you don't talk about inches and miles, you talk about centimeters, kilometers. So we're going to be converting in both of those systems, and then we're going to go in some of the problems, we're going to convert between the two systems. We're going to go from English to metric or from metric to English. Sometimes we'll just stay within one system. In other words, I'll give you something in English units and you'll convert it to some other unit that's in the English system. Same thing with metric. Sometimes I'll stay within the metric system. Those will be the easiest ones because I'm going to teach you a little shortcut, a little saying that you can use to get you out of the conversion steps that I am going to be using in about 75% of the cases, because you have to. When you're converting from English to metric or metric to English, you're passing in between both systems. You have to do full-blown conversion, or if you stay English to English, metric to English to English, you also have to convert. So we're going to put all of that down on paper, what I just verbally introduced the section with. Let's move to section 2.4. I was just talking about, take notes again. Hopefully you're printing these lesson notes packet, because for you to start creating all this will cause you not to be able to keep up with me. I specifically am pointing out to you mainly because it's almost time for your second test. I am on the 4th of 5 sections. I only have one more left to teach, and that's going to be on next time I see you, which will be Monday, and the chapter will be done. So because we're so close, you want to start getting your note card ready and making sure that you have those that you're working on the portfolios, because the portfolios are always due on the last day that the testing window is open. So just things, to keep your eye on. I like to make, if somebody says, I've never taken a math class where you could use a note card, but if you're in a class where you can make a note card, it's kind of easier if you just throw the formulas on there from each section as you go along. And what I would do is every time I get to a section where I think I'm going to need some things, I would throw it on the note card. So what if it fills up 3 note cards? Then when you go to review, you start condensing it, and you'll see that by then there are certain formulas that are really sticking with you, and you don't want to waste space on your note card putting them on the note card. And then there's some that you really need to have. And so it's kind of a review. Not only are you condensing your note card, but you're reviewing at the same time. Okay, so let's start. I pointed out to you that all the conversions can be found on page 192 in your book, whether you're using the e-book that I've shown you a couple of times how to find, or whether you have the hard copy book. Hopefully you just have the hard copy book, because it's much easier to find what you need. So this is page 192, and these are the kind of things that you're going to want to put in your card. I can give you a way to avoid having to put this entire table on your card. I'm going to give you a little saying that will allow you to go from one metric unit to another metric unit. Whether you're going big to small or small to big won't matter. So you don't have to copy anything from there. Some of them you might have memorized. Like if you know that you know this by heart, that there's 12 inches in 1 foot, then don't put it on your card. If you know there's feet in the yard, don't put that in your card. You get what I'm saying? So you'll notice that when you're in the English system, those are the ones that should be the most common for you, unless you were raised in a different country. And then that country's accepted form of measurement would be more familiar to you. But the English system, we use feet, yards, miles when we're doing length. For weight, yeah, Lewis, you might be having, yeah, let's get some feedback here so we can answer Lewis. Can people see this document, Camera? Yeah, okay, because on my end it says that you're seeing it. Lewis, why don't you try and sign out and then come back on? Just, sometimes it's just funky and it does that. Okay, so I was talking about how length is those units, and then when you're measuring weight, we use ounces and pounds and tons. Those are familiar to you. When you're measuring liquid, it's tablespoons, cups, pints, quarts, and so forth. Time, seconds, minutes, hours, days. These are just common units within the English system. Okay, this, I wouldn't put that on your note card. You'll wait and see how I do those metric to metric problems. This you're going to want. What this table does right here, and you're going to want those temperature formulas as well. What this does is it relates everything in this table to everything in this table. So in case, for instance, when you're going from one country to another, let's say all of a sudden you had a job and you're in another country and they're in the metric system, as many countries are, then you're going to want to know what is equivalent to a gallon. Maybe you have, items with you, like let's just say that say how to make a recipe. You're looking it up in a recipe and it's all in English units or it's all in metric units, and that doesn't make sense to you, so you want to convert it to English units. So you have to know how to go between, even though I'm sure on your phone or an app or anything, you can get those kind of apps to just do the conversions for you. But here, you're going to be showing your work. See, that's the problem. If all you can do is do it on an app or a computer, then you're not showing that you actually know how to do the work that's associated with it. And unfortunately, that's what you're getting your grade for in any college class, being able to support your answer. So don't give me this just a final answer on the test, because you will not like what you see as a grade. I won't be able to give you any points because there'll be nothing for me to grade. Okay, here we go. So all that was about me showing you page 192 is just so you can remember that when you're in the English system and we're talking about length, common units are inches, feet, miles, things like that. When you're in the metric system, common units are, for measuring length, kilometers. Meters is what we measure in. Centimeters, millimeters. Okay, so common unit is meters, and it could be, this is 1,000, this is 100 meters, this is 1/1000th of a meter. They get tinier as you go to the right, but again, I'm going to demonstrate that. Okay, when you're talking about weight, when you're talking about weight, we use ounces. When we're in the English system, we use pounds. We use tons. That was just all stuff that was in the table. And then when you're in the metric system, we use what's called grams. That's for weight. But again, you can still use these little abbreviations here. Instead of calling it a kilometer, you could call it a kilogram. And instead of a centimeter, it would be a centigram, and so forth. and a milligram. Okay, when you're talking volume, liquid that you're trying to measure. Common units for us would be a cup, a pint, a gallon. When you're in the metric system, you use what's called, so for length in the metric system, they use meters. For weight, when you're weighing something, it's grams. And when you're doing volume, it's liters. See, they have an easy system because it's just one word. And then you can put the kilo, the centi, the milli. So here it would just be kiloliters, centiliters. And you could put CL. Sorry about my crazy looking L's. They're kind of curly. All right, so I put all the prefixes for you here, although it's also on page 192. That's where you're going to make your note card from. This is a little saying that's going to help you whenever you are moving within the metric system. So if I give you a metric unit to start with, and then I ask you to convert it into another metric unit, that means you're going from a metric unit to another metric unit. And that's when you can use this saying. So you're going to want to memorize saying, but that beats the heck out of memorizing or putting all of that on your note card, because you don't have that kind of space on a note card. It's only supposed to be 3 by 5. So this will take the place of the table. King Henry danced Monday. Some people say King Henry died Monday. The saying sometimes goes like that. King Henry danced Monday drinking chocolate milk. So for King, K, for Henry, H, and so forth. Danced, the reason a lot of people use the word danced is because there's two things that start with a D here. The DA in dance will remind you that this is decameters. And remember, you can use all of these letters for, it doesn't have to be meters. It could be grams. It could also be liters. But it's going to start with a DA. I think that's even one of the questions on the test. Like they'll ask you, what is the difference between DAM and just DM? So D is for deci. This is for deci. This is for decameters. So the M that you see right here would be for, you know, they use an M for Monday because this was designed for when you're talking about meters. And I'm going to change this a little bit. This is King Henry. This is for decameters. This would just be the basic unit meters. But remember, this, you can use grams here if you want. Then it wouldn't go exactly with the saying, but it's still better than copying that whole table. You can use meters in the middle or grams or liters. Any one of those can go in the middle. But these are always going to be the same. So notice that up here, I give you the prefixes that go with KM. So KM would be the abbreviation, and it stands for kilometer. So you're not going to just use K, but just for purposes of having like a little saying that you can move through in order to get the answer, that's why we only have one letter for each. So this King is for kilometers. I'm going to put some extra letters here. Henry is for hecto. See, HM, hecto. This is for what we call decameters. You actually spell it longhand like this, D-E-K-A, but you abbreviated D-A-M. So this would be decameters. This is decimeters. These are the bigger units. These are the big boys right here. And then these are the little kids. These are the smaller units. Little baby versions of the meter. So this would be a decimeter. And you can see it right here. DM, decimeter. I spelled it out for you here. This would be centimeter, just like it says in the table, centimeter. And this is little millimeter on the end. Okay, I'm going to show you how to use that though. All right, now let's see. Are there any problems here so far? No, just information. So my first demonstration will be how to use this in order to convert 53 meters to millimeters. Okay, so you're going to start with meters. That means you're right here in the middle. You can put, they left this blank, excuse me, they left this blank in the middle because it can either be meters, it can be grams, or it can be liters. We're doing a problem that's in meters, so I'm going to put M right here in the middle. I'm going from meters to millimeters. In other words, you're going to move with your pencil from meters to millimeters and count up how many spaces, and you're going to, pay attention to what direction you're moving in. Okay, so let's start right here at meters, and we're going to millimeters. Now, this is going to take the place of converting, because with all the other problems, when you're going English to English units or English to metric, you're going to have to actually do conversion. And I'll give you plenty of examples. These are the easiest ones, metric to metric. Okay, so from meters to millimeters, I'd have to move 1 space, 2 spaces, 3 spaces. And notice that I moved to the right. That tells you how to get the answers. You're going to start with the 53. Take note of where the decimal is in this number. Sometimes it'll be in between 2 numbers. Sometimes it'll be in front. And when you don't see one at all, it is said to be at the end. If you had to move 3 spaces in this little saying to get from meters to millimeters, this is an M. That's why I always put 2 letters on each one. Then you have to move 3 spaces with your decimal. However many spaces you moved here, that's how many spaces you're going to move in your answer, filling in any blank spot 0. So 53 meters is equal to 53,000 millimeters. Okay, let's do it one more time, and you can even try and do it yourself. Might want to jump ahead of me and see if you can get the answer. Okay, so if you were doing this one, the only difference is the decimals in between some of the numbers, but same thing. You're going to be moving from centimeters, that's your starting unit, and you want to end up at hectometers. So go find centimeters. Again, we're doing a problem that has to do with meters, so I'll put meters as the base unit. The base unit is one in the middle. Okay, I'm starting at centimeters, that's what this is, and I'm going to hectometers. So I'm going to have to move 1, 2, 3, 4. H is for hectometers. So I had to move 4 spaces. 1, 2, 3, 4. And that's exactly what I'm going to do with the decimal. This time they actually are showing me where the decimal is. So that's where I begin moving it. And I have to move it. Notice that I moved to the left when I went from my starting unit to my ending unit. So that's which way you need to move this decimal. Here I moved to the right because to get from meters to millimeters, I had to move to the right. And so that's which way I moved the decimal. But in this problem, I moved 4 spaces left, so I'm going to go 1, 2, 3, 4. Any blank spots get filled in with zeros, and what you're moving is the decimal. Like here, I was moving the decimal all the way to the end. But when it's at the end, you need not state it in your answer. That's why I did not state it in this answer. When it's at the end, you don't need to state it. You can put the comma in there. That would be nice. In this problem, your final answer is just 0.00604. The decimal moved from there to there, and you are now in hectometers. You can just, fill it right in, put it right into the blank spot. 0.00604. Okay, moving to the next page where you're going to actually start converting by what's called Now this is the name for it in math classes as well as all of your science classes. Okay, now even if this is really simple for you, I'm going to do the simple ones by the proper procedure called dimensional analysis, so that when you get to the ones that require 2 and 3 steps, you can handle it because you know how to make certain units go away while converting into the unit that you want to convert into. So baby steps towards that. We're starting off in this one with 40 inches and we want to convert to feet. So you're always going to start with whatever they give you. When you're using, okay, we don't have any table. We're not counting our moves. That's from metric to metric. This has nothing to do with metric. Okay, you're going English to English units here. So you always start with what they give you, but abbreviate it. Don't write it as a word. You can just use the abbreviation for inches. Put this little thing that we call the converter fraction, and they are referred to as a unit fraction. That means one of the numbers in the fraction. Unit means one in all, no matter what kind of math you're studying. So this means that the fraction, one of the numbers, either the top or the bottom, is going to be a 1. Now, how do you decide how to set this up? First of all, it is mandated that the unit that you're starting with right here, one that you want to go away. Therefore, since inches is up here at the top, the only way you're going to get that unit to cancel and go away is if that same unit is in the bottom. So from the very beginning of the problem, as soon as you write this here, you know that the unit there has to match the unit here. Okay, then look at what you're trying to go into, because what you're trying to move into is the unit that goes at the top. You should always have in this unit fraction a unit at the bottom, which will match what you started with, and a unit at the top, which will be the one you're going into. Now you want to go and grab some equivalency off of the table on page 192, or maybe you're just grabbing it from your brain because you have it memorized. There are 12 inches. You better put the 12 right next to your IN, which is equivalent to 1 foot. See how one of these numbers is a 1? These numbers get dumped into your fraction, and they create what's called a unit fraction. Okay, so it's 12 goes with inches is equal to 1 foot. And this guides you into whether you should be multiplying or dividing, which is easy in a one-step problem, which is what you're doing, what we're doing right now. But when it becomes 3 steps, then it's a little bit confusing. So learn how to do it for the easier problems so that you are able to transfer those skills to the harder problems. Okay, when you're multiplying fractions, it's top times top, divided by, that's what this means right here, whatever is in the divisor, which is the 12. These units are gone. So you are now in feet. You're going to be graded on whether you know what the correct unit is, how you set this up, and that you are able to finish the problem. Let's see what this says. So this was the feet should appear. Okay, so inches should appear in the numerator. Oh no, sorry. Denominator. They're talking with this question that they're asking right here. They're talking about this unit fraction that you just set up. So inches should appear in the denominator. That's the bottom. That was the first decision I made. Since this was inches, that needed to be inches. And feet should appear in the numerator. That's the top. That'll be what you want your answer to come out like. We wanted it to come out in feet. So now you're going to want to, usually they want you to convert this to a decimal. I mean, if they tell you not to, if they don't ask you to convert to a decimal, here's 2 possible ways you can give your answer. You're at least expected to reduce this. Like 4 goes into both of these. And anyway, your calculator will reduce for you. So you can reduce on your calculator, or you can do it by hand. 4 divides into both of these. It divides into the top. It divides into the bottom. So this would be the most reduced way to give your answer as a fraction. And if you're going to put it in your calculator, we learned in chapter 1 how to put things that are fractions in the calculator. Just top divided by bottom. And you get 1 point. I'm going to round it to the hundredths place. You get 0.33333. It's just a run-on. You can put the little bar there if you want to, or just round off to a specific place. Now in Alex, they're probably going to tell you which place to round off to. So there the answer is as a fraction. It's just this, reduced, and there it is as a decimal. Okay, let's continue. I have plenty of these because these are the harder ones where, well, they're harder than using King Henry died Monday drinking chocolate milk or danced Monday drinking chocolate milk. Okay, 8 feet, and we're going to centimeters. Okay, so now we're starting with the English system. Pay attention to this so you know where to find these numbers. We're starting off with an English unit, feet, and we're going into the metric, a metric unit. That means we are mixing the two systems, the English system and the metric system. So on page 192, you're going to go and look for any little equivalency that has feet and centimeters in it. So here's the tables on page 192. Okay, we're looking for feet and inches if we can find it. If you cannot find that exact bit of information that you need that has feet and centimeters in it, did I just say feet and inches? I think that's what just came out of my mouth. We want feet and centimeters. Then it might be a two-step problem. Okay, so let's see. Feet and centimeters. We have inches and centimeters. I think that would be good because it's once we get it into inches, it's not that hard to get it into feet. So let's see, we don't have anything that has centimeters and feet in it. So this will be a two-step problem. We can take ourselves in the first step to inches, and then we can go to inches to feet. So we're gonna use this bit of information right here. 1 inch is equal to 2.54 centimeters. Okay, so put your little converter box. Okay, watch what I do here. Whatever you have here, and I'm going to write what I just, it's already here. Yeah, so we're going to use both of these. It's trying to give you in this package that it is 2 steps. That's why there's 2 equivalencies here. There's this equivalency, that's going to be one of the steps, and then you're going to use this in another equivalency. You're going to have 2 fractions. First, why don't we go from feet? You already know you have to put feet here because whatever they start you with, you must copy down here. That is the first thing you're going to get rid of, whatever they start you with. You're going to go into some other unit. Now, I only have here to work with, what do I have here? The only thing that has feet is this one right here. 1 foot's equal to 12 inches. So I'm going to put inches up here, 1 foot. The 1 goes with feet, 12 goes with inches. That'll get rid of feet. So feet don't exist anymore. Now you don't plug in the numbers at this point. You keep going until you have the unit that you want for your answer. We're trying to get into centimeters. Don't stop setting up your fractions until that unit is at the top of the fraction, and that's going to happen in this very next step. Okay, just like I took this unit that was up here at the top and matched it with this one on the bottom, I'm going to do the same thing again. The unit that's at the top now, I'm going to match at the bottom because I want them to cancel. What I want to go into is centimeters, and I do have an equivalency for these two. I know how many of these are equal to how many of these. It says it right here. Should have scribbled all over it, but here it is right here. It's also on the table on page 192. That 1 inch is equal to 2.54 centimeters. 1 inch is equal to 2.54 centimeters. So this is a 2-step problem, 2-step conversion. Okay, I made the feet go away. Those canceled because you have the same unit, top and bottom. Again, you have that happening again, but for inches, same unit, top and bottom. That's what makes them cancel. Only unit that remains at this point is centimeters. So your answer will be in centimeters, and then you're going to get your calculator to assist. If you're confused about whether the 8 is at the top or at the bottom, it's at the top. 8 is the same thing as 8 over 1. So I was talking about this yesterday when we were doing the area and the volume formulas, because there was a lot of fractions in those. But the fractions had, divisors also. So the way you put this in your calculator is get all the tops multiplied. And then if there's any number down at the bottom that's not a 1, if there's any divisor other than 1, then you can go divided by. Now, all you have is 1s here. So therefore, once you get the tops multiplied, you don't need to push divided by 1 because it's not going to change anything. But if there were numbers down here other than 1, then yes, you would, after you get this all multiplied out at the top, then you would push divided by, and then the number is there. We don't need to do it here. Okay, so it's just 8 times 12 times 2.54. And I get 243.84. Okay, so a two-step problem. Two-step conversion. This was a one-step conversion. Okay, moving to the next page. Okay, this is just a little review at the top that whenever you move from the English system to the English system, like in the first example that I just did right here, okay, those are English units, and I was going into English units. This is English to English, and so I did dimensional analysis. Or if you're going from English to metric, you will still do dimensional analysis. And when you're going from English to metric, it's not always going to be 2 steps. It could be 1 step, it could be 3 steps, it could be 4 steps. It depends what you have available on the table to convert them. So those are the times that you're going to do dimensional analysis, and that's what this is a review, to see if you understand that. Whenever you're going from English units to English units, dimensional analysis. Whenever you're doing English to metric, you're moving in between systems, also dimensional analysis. Here, you're just going to move the decimal metric to metric in that saying, King Henry died Monday drinking chocolate milk. That'll get you out of the dimensional analysis. Okay, so in this next one, it's a little word type problem. It's just a little verbal in there. If a car is traveling at a speed of 75 miles per hour, now when they mention 2 different units here, that is known as a rate. So 75 miles, see that right there? That word represents the division bar. So you're writing it as a fraction. A rate is a fraction. And this fraction happens to be something that was mentioned on the previous page. It happens to be called a unit fraction. One of the pieces of the fraction will be a 1. Okay, 75 miles per hour. They're talking per every 1 hour. You could read that 75 miles divided by 1 hour. Now this says, what is the speed? Because rate is the same thing as speed. Speed and rate, they mean the same thing. So if you want to put that there and you didn't know that already, write that right there. So what is the speed in kilometers per hour? So what they're telling you, what they're trying to tell you here is to get this rate, this speed that they're giving you right here. I called it a rate, same thing as speed. They're telling you to get this in kilometers per hour, not miles per hour. So if they want kilometers instead of miles, that means you got to get rid of miles. You need to get rid of the miles. How do you get rid of a certain unit? Let's review what I did in this last problem. You have to understand dimensional analysis. When I wanted to get rid of inches, I made sure that that unit appeared top and bottom on two different levels so that they would cancel, so that inches would go away. In this problem, when I started off wanting to get feet to go away, I made sure that the unit I started with matched down here, just like this problem. You're going to want that first unit to go away so that you can convert into something else. And this is what makes it go away, that it appears on two different levels. Then I wanted inches to go away. So I had inches at the top at that point. So I designed the next unit fraction so that it was at the bottom. And so that made those go away. That's the same thing that you are doing here. You want miles to go away, so let's set up this dimensional analysis. If there's miles here and I want it to go away because I want it to be kilometers as they've asked me for in this problem, then I'll make sure that miles is here. That'll make that cancel. And the unit I want to go in, kilometers, will go up here at the top. Then I'm going to go to page 192 and look for how many miles is equivalent to how many kilometers. So let's go over there and see. Again, this is English units. These are metric units. So you're in the table that relates English to metric, which is this table. It's the third table down. Okay, this is English to English. This is between systems, metric and English. All right, so what did we have? We had kilometers and miles. Let's see if there's anything here that talks about kilometers and miles. Here we go, right here. 1.61 kilometers is equal to, those little squiggly marks mean approximately. That's because they've rounded this off. So 1.61 kilometers is equal to 1 mile. So I will be able to set up that unit fraction. One goes with mile, 1.61 stays with kilometers. So 1.61 with kilometers, and then a 1 goes here for miles. And in this way, miles is gone, and now I'll still have a rate left over. A rate is something that has two units. It has a unit at the top and the bottom. So if you started with a rate, you're going to end up with a rate. What you're just doing is taking things that were part of the rate, units that were part of the rate, and they're asking you to change one of them. Sometimes they can ask you to change both of them. Okay, so here we go. So now it is, remember, anything that's at the top of the fractions, those are all multipliers. The only things that these numbers are down here, those are divisors. You divide using those numbers. But if all they are is ones, don't bother. Just 75 times 1.61 and you'll be done. Whoops. 75 times 1.61. And you get 120.75. I'll give that to the hundredths place. And then write the unit that goes with it. It's kilometers at the top. That didn't cancel with anything. Kilometers per hour. And you can extend that bar all the way across if you want to. Okay, with regard to this, as the Earth revolves around the sun, it travels at a speed of 18 miles per second. This is also a rate, or what we call a speed. And I'm going to write that 18 miles per second. 18 miles divided by means per. You can read it as per. It's the division bar. Per second. They're talking about 1 second. Okay, at this speed, how many miles will the Earth travel in 4 minutes? Okay, you want to be able to multiply this by 4 minutes, yet this is not in the right unit. So what you're going to do here is you're going to make sure that you get this to a place where you get it into minutes, and then you can multiply by the 4 minutes. So right now, let's get rid of seconds. If seconds appear at the bottom, the only way to get seconds, the unit seconds, to go away is if you make it appear at the top. Okay, I see that there are minutes in the problem. They're trying to nudge us over to a point where we're using minutes. So I'm going to relate seconds to minutes, and most of you know that already, that there are 60 seconds in 1 minute. So I'm doing my dimensional analysis. I'm getting rid of seconds and dragging minutes into the problem. So right now, I'm in miles per minute. Now, I haven't done any of the math yet. I haven't put any numbers in my calculator yet. I can now, because I have the unit of minutes, multiply by 4 minutes. This is not a rate, but you need, in order to multiply by what it's doing in 4 minutes, you needed to get it in the right unit. So now when all is said and done, this is you go 18 miles per minute, but you're traveling for 4 minutes. So every minute you're going 18 miles. That's going to happen as you put these numbers in the calculator. These are all multipliers because they're all numbers at the top. Only the bottom numbers are divisors, but those divisors don't matter if they're all ones. Anything other than a 1 matters. So you would use it at that point. So on the top, 18 times 60 times 4, 4320. And this would be, let's see, minutes are gone. Those units cancel because I have 4 minutes is the same thing as 4 over 1. So those minutes are at the top, those minutes are at the bottom. So the only unit that's left here is miles. And that's the question. How many miles will the Earth travel in 4 minutes? Okay, let's see if there's any others. Okay, there's this one last page, and then we're going to move to the activity that's in Socrative. Okay, so these are, again, some more multi-step problems. So in this one, it says it gives you the ratio that 1 mile is equivalent to because that's what these fractions are made out of, things that are equal to each other, equivalencies we call them. 1 mile is equivalent to 1,760 yards, but you can take this and flip it over if you want. Just as long as the 1760 remains right next to the YD for yards. That's what you can't change. You can flip them over, but if one is with miles, then one should be with miles even when you flip it over. Same thing here. 12 inches is equivalent to 1 foot, but you can use it like this, or you can use it like this. Notice that the 1 is with FT, and it's still with FT. 12 is with IN, it's still with IN. And then they have one for inches and yards. There's 36 inches in 1 yard. You can flip that over. You decide whether you should use any of these fractions in this form or this form based on what you're starting with. Like, for instance, as I've pointed out in all the examples that I've done for dimensional analysis today, if you start with feet, you have to have feet down here, because how is this problem going to move forward? How are you going to accomplish anything unless you get rid of the unit that they've started you with? And that unit can only go away if you have the same unit on 2 different levels. So I'm locked into that. Now let's see, what does this say? 108 feet tall. How many inches? I'm moving towards inches. So if I'm moving towards inches, I already know the feet has to go there, and the unit that I want to go into can sometimes happen in just one step if I know the equivalency, and I do. I'm doing 12 inches is equal to 1 foot. So in this case, in this particular problem, I needed to use this converter fraction with the inches on the top, feet on the bottom. I was dictated to do that because of the way this problem started. If this was feet, this was feet. Now we have multipliers of 108 and 12 on the top, and we don't have any divisors that matter. So to finish this, it's 108 times 12, which is 1296. Okay, last problem. Now this is going to be several steps. That's why all these blank spots are here. It says a swim race has a total distance of 25 miles. Okay, so they're starting you with the 25 miles. There's no unit down here because this is just the number that it's starting with. But again, if this is miles, this has to be miles, or else there's no way to move forward. Unless you're getting rid of the unit that they've started with and you're getting rid of that, there's no way to make progress and move forward in the problem. So let's see, what else does this say? Race officials want to mark the course every 500 yards with a buoy, including one at the main finish line. How many buoys are needed? Fill in the blanks on the left side using the ratios shown. Okay, so as I look through all these things, okay, so let's see, what else do we have in miles? We have, we can go miles into feet if we use this first. I'm dictated into using it in this form because if miles was here, miles was here. So it is 1 mile is 5,280 feet. Okay, whoops, don't forget the units because those very much matter when you're doing dimensional analysis. That'll get rid of miles. Now I'm in feet, so now I want to use something that has feet in it. The units that they're giving you here are the equivalent between feet and yards. Again, if feet is up here, if you're going to move forward in this problem, you need feet to go away. So if feet is up here, putting it on the opposite level will make it cancel. I'll write this a little bit nicer. Okay, and then what do we have here? We have that 3 feet is equal to 1 yard. I'll be using that. 3 feet is equal to 1 yard. We finally have a divisor other than 1, so we are going to have to press that in. At this point, feet are gone. I'm in yards. I want to use a converter that has yards in it. So as I look here through my choices, here's one with yards in it. Every 500 yards, we're going to put a buoy. We're going to mark it off with a buoy. So if yards is here, I need yards to be here. And then they're placing these buoys that are in the water every 500 yards. So get the numbers right here. 500 goes next to yards. 1 goes next to buoy. Yards are gone. Notice that the only unit that has not canceled with something else is buoy. That's why they have that in the final answer. To get everything calculated, you're going to have to multiply all the tops and then start dividing by any numbers that are not ones, the 3 and the 5, one at a time. Okay, let's get the tops multiplied out. I'm going to put this in the calculator. 25 times 5280. Those are the only numbers at the top that matter because you're not going to multiply by 1 successively because it won't change your answer. So 25 times 5280. Get that big number at the top, and then my divisors are, first one's 3. So just push divided by 3. You can press enter, hold that answer. You're not there yet because there's still one more divisor that matters, that 500. Anything that's not a 1 matters as a divisor. So now push divided by 500. And you end up with 88 buoys. So if you have 25 miles and you're wanting to put a buoy every 500 yards, you want to place a buoy, you're going to end up needing 88 of these markers called buoys. Okay, that's it for the examples. So now we have 20 minutes left. I think there's 10 problems on this particular Socrative activity, and I wish you would really call on me if you're stuck on something. Please don't let yourself get a 30 or a 40 just because you don't want to ask a question. I'm going to put people in groups. I have made everybody a presenter. So in case you want to show your work, oh, there's 3 people that slipped in after that. So let me make them presenters. And then, Cheryl, do you have a question?
Yes. Hi. Good afternoon, Professor. So
Hi, how are
I'm
you?
not sure I'm able to do the Socrative. I'm literally on my cell phone right now, on this little iPhone 5, and I don't know if I'm able to do it. I don't have Wi-Fi. I'm just moving to a new home today, and I don't have Wi-Fi yet. I'm waiting for Comcast to come out. So I'm doing this by my cell phone. Is
Okay,
there?
yeah, no, they are totally doable on the cell phone. In fact, I do Socrative and Go Formative. I do all these things in my face-to-face classes all the time. And typically, we don't
Okay.
have
I'll try.
computers with it. We just do it on our phone. So you're totally going to be fine on your phone.
Okay.
Okay, just use your mobile data. It eats up very, very little data. So you'll be fine just using your mobile data. And I'm going to switch over to that now. But please ask me questions if you get stuck on any of these problems. Hold on while I open up the classroom, and then I'll tell you when you can get in. Let me go and open that up.
Okay.
Okay, everybody, you can get in. I'm going to put you in groups, and then I'm going to visit each of your groups to see if you need me or not. Or you can just verbally say out loud that you need help. Okay, so go to Socrative, Socrative, Socrative.com. Don't forget to put your last name in as well as your first name. And the name of the classroom is Zeiss. I mean, I probably don't need to say that anymore. My last name is Zeiss because you've used it many times already. And you can start asking the questions, answering the questions. When you're done, you can just leave the session. Let me try and put you in groups.